Hello, my name is Erik and I'm with Building Point Scandinavia. Today I'm going to talk about numbering. Sometimes we get questions regarding numbering on the support, and I would like to throw some light on the topic. Okay, we are now in the prepared model, and under the numbering settings we have this form. Under the numbering tab we have renumber all, reuse old numbers, and check for standard parts. Renumber all is pretty easy to explain. That will renumber every object in the model based on the settings you have set in this form. Let's look at option number 2, reuse old numbers. Let's use this column as an example. Column today is called SS1. If I delete that column and add another column exactly the same size, same material, and I do a numbering of that beam or column, you will see that Tekla has now taken the next position. It means it's called SS2. If I again delete that column, tick on the reuse old numbers and apply that setting, and do another column exactly the same space, same area, everything the same is similar, and do another renumbering and check the number. The number has now been given 1 again. So that's what it does. It allows Tekla to reuse already used numbers. The third option is check for standard parts. The check for standard parts is a way for Tekla to look inside another model, a standard parts model, to see if there is a similar object in that model. In this model, this is something typical you have for secondary parts or parts in your model. It could be like you have like a angle or as a plate, which is standard. Let's have you have like hundreds of those in your shop. You produce them for reuse, and you always use these plates and these angles. Looking at them, you can see that they are called, in this case, I just call them, you can call them whatever you like, but in this case it's an L100, and I call it 2B, which is 2 bolts. This one is a L100 and 3 bolts. If you look at the other side, you can see that I have a plate 10 and 6 bolts and so on. So this is a plate 10 with 4 bolts. It's very important to remember that you can save a standard parts model, but you should never ever number a standard parts model. It only works for parts. That's another thing to remember. So never renumber it or number it, or and it always only works for parts. So let's go back to my production model here, and I will tick the standard parts on and apply that. Over here I have an example. You have a just quick look at what we have. let's see now. Oh, sorry. Here I have an angle currently called P1, and you can see that the prefix is P, start number is 1. We have another one here, also P1 with 2 bolts, and here we have a P1 with 3 bolts. On the other side, I have a 10 millimeter plate, which currently called DSP1, and it's also this one has 4 bolts, and it's called also have the prefix DSP1. So you can see I do the check for standard parts. So I do numbering. Tekla runs for that. And now I'm going back and I'm going to check this part. And you can see now that the part position is now L100 by 3 bolts. This is L100 by 2 bolts. It was exactly the same that I gave it in the standard parts model. Here I have 3 bolts, which is called P3, and the reason is that this part do not exist in the standard parts model. Looking at the other side again, my plates, you can see that this is called a P10 by 4 bolts, and this is a P10 by 6 bolts. Okay, moving on to the next part, which is new objects and modify objects. In the new objects session, you have 2 options: compare to old, and you have take new number. It basically means that if you have a new beam, and you have this one, it will compare it to the part in your model. It will actually look for the part number, and it will give it the same number. This one will give you a new number. So even though there exists one already in your model, this one will actually take a new number, which it says. On the modify part, they have added one option, which is keep number if possible. It's exactly the same meaning as on the new part. It means that if you have compared to old on, it will compare the modify part to existing and change the number to the existing one, or it will definitely take a new number. The keep number if possible is something that is not always bulletproof. It means that if let's say that if you have like 10 or something columns, and you change one of them, Tekla will definitely not keep the number for that one. It will change the number for the one. On another example, if you have 2 parts that are different, and you change one of them, and you have keep number if possible, Tekla will not change that number either. So this is an option that needs to be controlled. So you have to have, what you have to do and what you should do. Moving on to synchronize with master model, save number, save numbering, save. That's our option that was very much used during multi-user. I would say it's a good reminder of what you should do, that you should save the model before you number, and then do your numbering, check the numbering, and then do another save. So, but with this box ticked, and I do apply that setting, and I do this numbering again, it will give me a report. That's what's going on during this numbering. And you have the option of saving the numbers, or you can do stop the timer. In this case, I'll just stop the timer, and Tekla will revert back to before it started the numbering. So nothing has happened here. But anyway, this is a good way of being reminded of that you should do a save, do a numbering, and then another save. But again, I haven't, it's not very much in use anymore, I think. Automatic cloning is something that we know something about. Everyone knows that you can clone a drawing or something if something happened. Let's say that you have two similar columns. I will add another one. So here I have two similar columns. Just do a quick numbering. Just tick that off. Apply the setting, and I will just do another numbering. So now I have two similar and similar columns. I will just quickly make a demonstration of the cloning thing. So you clone the drawing. Let's say I do a fabrication drawing. I'll just do an assembly drawing, and I'll just apply the, doesn't matter. Create. Opening the document. You can see that, let's get rid of those two. You can see that I have one drawing that's representing both of these columns. If I change, let's say, the height of this one, let's do that. Manage. Change. Do another numbering. Tekla will try to keep the same settings, but it will create a new drawing for you based on the same settings as the previous one. So that's Tekla's way to help you in your drawing production. We also have compare and tolerances. They are pretty much the same, but this is Tekla's way to compare what is the difference between parts or assemblies. So you can see that in this case, this setting will compare holes and names and also assembly names. So I will do just a quick show that really quickly. Here I have two beams. As you can see, this one is SB12 and this is SB13. This one has two holes. This one has just one hole, and that will actually tells Tekla to compare holes. Okay, so they are different. In this case, I will, let's say, just turn that one off, do another apply. I will just, put a renumber all just to make it correct. Do another numbering. And in this case, let's see that this is SB11 and this one is SB11. So it actually ignores that you have the number of holes you have in your model. That's basically how this works. So, and the same for if you wanted to compare directions, and that will also influence on your numbering. Just something to be aware of. On the tolerance part, it will work almost the same. I have another example here. I have two plates, which, you know, they are definitely different size, but the tolerances are more on the graphical part of the numbering side. So you can see that these are different, and you can see that this one has DSP3 and this is DSP4, and they have different assembly numbers and all of that. So what does it compare? It compares steel, which means that the tolerance, everything within tolerance 2 millimeters are the same, and compares to concrete and rebars and other stuff. So let me just do a quick change of the tolerances. Let's put in 500, for instance. Do our numbering, and now Tekla tells me that these two parts are the same. That's how this works. I'll just put it back to 2 millimeters because I think 500 is a little bit too wide. Assembly position sort order. I have prepared a small demo model just to demonstrate that part. Just let me open this settings again. I'm sorry, settings. And you can see that in default values inside Tekla, you can see that it's X, Y, and Z. So that means that Tekla number these parts from X for 0 and out. So you have 1, 2, 3, 4, 5, and then in the Y direction and in the Z direction. So if you look at this part is SB1, this will be SB2, and this will be 3 and 4 and so on. On the column side, 1, 2, 3, and 4. If I flip these to descending, do an apply, and I renumber, yes, and you can see I have renumber all just to make sure that everything works perfect. No, this is SB4, 3, 2, and 1. So it flips it the other way around, and the same for this side. I'll just bring back the ascending part and just apply that. So you do have some options here as well, and you can change the X, Y, and Z directions how you like, and you can do what we call a main part user defined attribute that could be used as sort order as well, and also user defined attribute. In most cases, I think that these are pretty similar. On the main part, user defined attributes is most of the main part attributes will be pushed up through to the assembly, to the other parts as well. So I will just flip those, change that to the main. And as you can see, it's not all of, so this is just user-defined attributes that can be used. So this means that you cannot use profile, for instance, you cannot use that as a sorting order. So because you cannot find it in this list. In some cases, maybe I will just make a quick short demo of how we can use this. You can use extension called copy UDA. If I just open this one, hopefully it will start running soon, and you get this form. You can see that I have added my smallest profile here, and it goes larger, and the other way, opposite way on the column side. So I will use the profile file, and I will as a source, because I will add this as a the profile as a UDA, and you will find it in the user field UDA, user field 1. So doing that, I will not make any more difficult than that. You can also probably use some filters and so on, but I will just do that. I copy all of them. So and I will change this to user field 1. Find it here. User field 1 in this area, and user field 1 in the set direction as well. We'll apply that. If I now do a numbering, before we check that, I will just have a quick look at the user-defined attributes and see if everything is okay. So as you can see, this profile has now been added to the user field 1. So it's now been added as a UDA. So I did a numbering, and what you can see that in this case, Tekla will give it SB1, which is the smallest one, SB2, 3, and 4. Here you will see that this one will get SS4, 3, 2, and 1. So it actually brings it from the smallest one to the largest one. If I switch to descending, it will go the opposite way. This is one way to use the main part user-defined attribute. That pretty much covers the numbering tab. We also have something called family numbering. Family numbering is not something commonly used, as far as I know. I've never used it in any of my years designing, but I will just quickly do a demo on how to use that family numbering. So the first thing you need to do is to add a series. So you can see that I have my plates and my beams and my columns and all that. So I will just use the in this case just use the columns. No, sorry, that's beams. And I will I will compare the main part profile and the overall length, for instance. I also have some other options there as well. So so you can see that what this do is to it compares the main part profile and just the overall length. So nothing else than that. So I will apply that, and I will do numbering. Let's see. There we go. Okay, so by adding this family numbers, you will see that it gives the beam a prefix, a running number, and then a qualifier. It could be the qualifier could be like like this, a number. It could be a letter or something like that. If I check this one, this is SB2. Again, another beam, but the qualifier is 1. And you have here shorter beam. This is SB3 with a qualifier of 1 again. So it will keep its running number because they are definitely different sizes. So the length is different. If we zoom into these beams, you can see that these are, at least they have the same length. So this is SB4 with a qualifier 1. This is SB4 qualifier 1, and this is SB4 qualifier 1. So, okay, it can compare the name and the length and the part profile. So they're similar. If we go to the next example, you have SB5 qualifier 1. You have, in this case, the one here is SB5 qualifier 2. So, okay, they have the same profile, have the same length, but there's something else that actually makes them different. And here you have, okay, this is the SB5 with a qualifier 2 and an SB5 with a qualifier 1. So these two of them are different. So just have a quick look at what's the difference between them. And in this case, you can see that the material is different. This is material S235. If I open this one, it's S275, and this is 75, and this is 235. So it's actually the material that makes these two these four beams not has the same qualifier, and that's how the family numbering works. Again, it's not something I'm really familiar with. I'm not sure if I know anyone who uses this, but anyway, it's a possibility. And for those of you who wondered what family numbering is, now you know. Okay, that concludes this numbering session, and I hope you found it interesting. And thank you for watching. Nei, ta faen meg. Det var litt surrete.